Hi guys, hope you all are doing good. So in the previous video we have learned how to insert a node at the beginning of a double linked list. So in this today's lecture we will learn how to insert a node at the end. So let us understanding step by step. So without any delay, let's begin our today's lecture. Suppose we have a double linked list. Suppose we have double linked list. Let me take. So null, so backward 10, forward backward 20, forward backward 30, and forward null. So this is our initially double linked list. So now we want to insert a new node containing 40. So new node equal to 40. So we need to insert new node 40 at the end of this double linked list. So that our final output should get so null 10 20, I mean 10 forward backward 20, 20 forward backward 30, 30 forward backward 40, and forward null. So this is our final linked list should be achieved. So what we have done here, we have created a new node equal to 40. We have inserted at the end of the double linked list. So that's the insertion at the end of the double linked list. So how can we do it actually? So let us learn. So to achieve this, we need to create a new node. So first we need to create new node. For that we need to create struct node, that should be start new node. So start new node. So we are created struct node new node. So now we need to allocate dynamic memory here. So new node. So using malloc function we have allocated dynamic memory to this new node. So we have successfully created the new node. So now we need to store data. So now data becomes new node data equal to 40. So this is our data. So we have stored the data in the new node. Now initially it's pointer. So in initially new node will be so this 40 is the last node, mean the obviously the next to this element will be null. So for that initially new node next should be null. So new node next is null. So why? Because it becomes the last node. So that's the last node means the next will be null. That's why. So now we must reach the current last node. For that we use a temporary pointer. So for that we are going to create a temporary pointer. Struct node, yes, start temp. So initially temp starts from the head. So we need to know the last node actually, right? To insert the element at the last of the linked list. So we need to use a loop. So what the loop actually? While loop. So while we are going to write temp of next what is not equal to null. So until temp is not equal to null, temp will be moved to the forward. So temp equal to temp of next. So this is our while loop. So this while loop creates the last node. That means while the loop finishes, temp points the last node. That is 30 actually in our example. Now we are going to connect the new node. First, we need to move the new node pointer to the backward. I mean, to back to the last node. So for that, we are going to write new node, previous equal to temp. So temp is the 30. So new node previous equal to temp. On the next line, make the last node points to the new node. So for that, we are going to write temp of next. So temp of next equal to, yes, temp of next equal to new node. So this is the we have inserted. Next, make last node points to the new node. So that means we are going to write. So we are already written, right? So now the double linked list becomes, so let me write again. So we are declared temp of next equal to new node. Now the double linked list becomes null backward 10, 20, 30, 40, and the null value. So this is our final linked list. So insertion is successfully completed. The two most important lines are these two. So let me write with yellow ink. So these two lines are very important actually. New node of previous equal to temp and temp of next equal to new node. Remember this carefully. So initially we have created the linked list is, so let me tell again. So from the first, so first we have the initial linked list 10, 20, 30. So now we need to create a new node with value 40. So set. So next value will be null automatically. So traversal until temp reaches the 30. So we are going to traverse the entire linked list until temp is equal to 30. So set we have created the, we have created the new node previous equal to temp, and temp of next equal to new node. So final list is the null is, so we are null backward 10, forward backward 20, forward backward 30, forward backward 40, and forward null. So this is all about the insertion at end of a double linked list. So let us see the C code for it. So I have all written the C code here. Let me explain it line by line. So these two header files are non-negotiable. We need to consider these two header files to write here. For stdio.h, we use this to write printf, scanf functions, and this htd live function is used to allocate dynamic memory, use malloc, realloc, and free. So we have created a node with data, int data, struct node, star next, and star previous. So in the main function, we have created the four nodes: head, second, third, and new node. For these three nodes, we have allocated dynamic memory allocation using malloc function, and we have given some details. So we are given some data here: head, previous, null. So we allocated data. Up to here is clear. So we are for the new node, we are also allocated dynamic memory allocation for the new node. So new node data equal to 40, new node of next equal to null. So this is okay. Now we are creating a temp variable. Initially temp equal to head. So we are moving temp to the last node. So we have created the while loop here. So new node previous, I have written this like this because I have no space here. To save the space, I have written like this. Please adjust for this video only. So temp equal to temp of next. So we have created the for loop here, right? So now temp points the last node. So now new node previous equal to temp. So we are connecting the previous of new node to temp. So temp of next will become new node. So temp equal to head. So this is what. So this is we are successfully created. We are inserted the element at the last end of the double linked list. So now our goal is to print the all values in the double linked list. So we have created while temp is not equal to null, printf percentage d temp of data, temp equal to temp of next. So this will be the print the all values in the double linked list. So let us see the output. So this is the output we are going to get: 10, 20, 30. So this is all about the insertion at end of the double linked list. So let me ask you some questions. Why is the new node next pointed to the null? It because it becomes the last node, obviously. If the last node always will points next equal to null. So initially 30 is the last node. We are inserting the 40. So 30 next becomes 40, and 40 previous becomes 30, and for 40 next becomes null. Automatically 40 is the last node. That's why. So why do we need to traverse at the list? So because we need to find the current last node. In the linked list we are going to access, we need to traverse entire linked list to access any node. When it comes to arrays, we can access directly using the index shell. So that's the main disadvantage with the linked list. So to find the current last node, we need to traverse the entire level linked list. So what is the time complexity? Can you guess the time complexity? This is the question. What's the time complexity will be? So takes your phone time and answer. So the time complexity will be for this. I am going to give a hint. So in this insertion operation, we are going to traverse an entire array. So the time complexity will be, yes, the time complexity will be big of n, because we may visit every node to reach the end. So we are reaching the, we are traversing the entire linked list to check whether the last node. So that's why the time complexity is big of n. So let me revise quickly. So first we have created a new node, we have stored data, and we are going to set it to the value null, and traverse it to the last node. We are going to set new node previous. So let me right here. So where's the important? So we are setting new node previous equal to temp, temp of next equal to new node, and insertion is successfully completed. So today we have learned insertion at end in a double linked list. So in the next video we will learn insertion at any position in a double linked list. So where you will understand how to insert a node between any two existing nodes. So I hope this lecture is clear to everyone. If you have any doubts, you can ask in the comment section. So don't forget to like this video, share with your friends, and don't forget to subscribe to our channel. So thanks for watching, and see you guys in the next lecture.